Hello, welcome to more Haskell live coding. Haskell live learning how to code. Um, I'm going to pick up on the VM again from last week. So last week I was starting to add local variables into the VM, just adding instructions for them, and I wrote a test for it. The test just checks that we can load variables and they get moved to the front of the stack, and then we can use them. I'm doing this because I want to use a lot of the same mechanisms for passing parameters into functions. So the idea is when I get this working, I can go back and look at using the same idea in a function when we call the function to pass stuff in, which will basically be the same thing. So it'll be copying stuff from one part of the stack to another, basically to the front of the stack, so it's available to the function. Yeah, I wrote a test last week. I created an instruction for loading stuff, but it doesn't work yet. I haven't implemented the step yet. So that's where I'm going to start, and let's just pick it up and carry on. So this is the test. What we're doing is our program pushes a bunch of values onto the stack, 4 different values. So the top of the stack, or the head of the stack, whatever, should read 4. Well, actually, it'll be 5 and then 4, working backwards. Normally, if you threw in a command like vm.add, it would just take stuff off the top of the stack, so 5 and 4, and add them together and give you 9. We have these instructions to load from position 0 and position 2, so it should load the value 2 and then the value 4, and they should be moved to the front of the stack, so when we call add, they should add them together. Plan, and if I run it, I think it doesn't work, so it gives back 9 as the answer. Yeah, so those steps for load don't do anything yet. So if I go to the code itself, somewhere inside run we should have this step, so step load, and all it does is return the CPU unmodified, apart from the instruction pointer. The instruction pointer tripped me up a bit last week. I didn't add this into my load step, which meant that it's never advanced instruction pointer, so the program never terminated. When I've implemented load, I want to do a couple of things to improve that. One is I want to move the modification of the instruction pointer out of this step, out of every step, so that the step just needs to worry about manipulating the stack and calculating values. And then the other thing I want to do is just put a counter into the VM itself, just to count how many instructions have been called. And maybe when we run 1,000 instructions, I'll just terminate it with some error because it's not going to complete if I run that many instructions. Okay, but anyway, back to the loading thing. So this should be really easy. So we will get 2 things out of the program. So we're going to need to pass the program in as well, actually. One will be the instruction itself, which is load, and then the next thing will be an operand, which will be the address in the stack of the value we want to load. So let me also take the program and just put into P. So what we want to do is we want to take the value of at the CPU IP plus 1. Right, so CPU IP, that's the current instruction. So that instruction will be the instruction to load, but we don't want that instruction, we want the next one, so it'll be plus 1. And we will store that in a variable, so we will say the address is equal to that. That's not in scope. What does that mean? What do you mean that? No. Yes, no. I've done this before. Where do we get the program? Thing exclamation mark. Sorry, wrong indexing. Okay, so we get the address back that we want to load. And then we want to do something with the stack. So let's get the stack out of here. What do we want to do with it? I'm going to write a new function in the stack itself. So we can say s dot, we call it s.load, and we give the address. We'll need the stack as well. And the result of that will be our new value. It's called v for lack of imagination. And I'll make this return either the value or an error. And then the final thing we want to do is we want to push v onto the stack. So we're going to return the incremented instruction pointer and also CPU stack is, I think it's s dot push will take some value v and the stack, which is CPU stack. Okay, that should be cool, except I need to define load. And I also need to pass the program in. But let's do load first. Load should be quite straightforward. Should be, I think. So at the minute, I'm just looking at the instructions I got before, so they're usually int and then stack. I think I called it with stack and then value. So I think it should be that way around, just for consistency. That might be wrong in general, but they're all like that, so I'll make it the same. So we're going to take an int and the stack and return either VM error or we're actually not going to return the stack unusually here. We're just going to return an int, one of the values off the stack. No, I made it int rather than word 8. Let's not do that now. So loading some address from the stack is, if I say that, and we can put in from, the trouble with this, I think, is that it just throws an exception if it can't find, if there's nothing at that address. Yeah, it calls error when element cannot be found. So I actually want a safer version of this. I don't know what it is. So I want something that goes from, I'm not sure when this will be. It's probably going to be a list of A. And from there, I want some int or int-like thing. And it should return to me a maybe A is what I'm looking for. So there's at may. Bang question mark. Okay. But this is in data list extra. Bang bang question mark in Prelude, which is what we're using, so we could probably use that. Bang 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 in Agda. Okay. But bang bang question mark looks like it might be the thing that I want. Safer version of bang bang. Okay. So that's what I'll use. Let me undo the import. And I will instead call bang bang question mark. Okay, so now it's returning a maybe type. I'm going to say case that of and just some value v is equal to pure v. Oops, not equal to. It maps to that, and nothing and then there should be some kind of VM error. We got anything appropriate in here? Invalid stack position, that sounds quite good to me. So this is going to be throw error, and the error we're going to throw is invalid stack position. Okay, so we can't match S like this. This has to be stack of S. Okay, that should be the implementation of load, basically. Or at least of fetching it. Yeah, the full definition of load the instruction will fetch it and then put it back on the stack, front of the stack. But this should be the thing that's just fetching it off the stack, basically grabbing some address. So now going back to here. Okay, we have a word 8. It expects an int. I could just do from, oops, integral. Goodness, from integral of the address. Okay. I always get sad when I have to do this. It makes me think I've done something wrong. But let's not worry about it for now. Everything else in the stack uses ints at the minute. This also needs a program. Okay. So in theory, that should be the implementation of load, so I can try running it and seeing what happens. One failure. Expected 6, but got invalid stack position. Okay. Wonder which one it doesn't like. Are lists 0 indexed? CI, so we can just create a list from 1 to 10. I didn't want to use this, I want to use RELUde. Okay, so A is a list from not there, where's dot? There's dot, okay. From 1 to 10. So A bang bang question mark of 1. From maybe, or from maybe is not available because it's unsafe. B is that. What B? For goodness sake. Okay, let's try this again. A is a list of 1 to 10 of type list of int. For goodness sake, stop doing this. A is a list of 1 to 10 of type that. Nope. Wow. Get the brackets right eventually. Shell existing binding. Try again. There we go. Okay. So A bang bang question mark of 1 is the value just 2. Okay, so it shouldn't be a problem with 0 then. So 0 does get the first element of the list. That's all cool. Okay, so it's nothing to do with not being 0 indexed. Let me go back to my test, and in the spec, so the stack should be it should be 5, 4, 3, 2. We load 0. Actually, interestingly, we load 0. I think we're actually going to get 5 back if this works. And then 2 would be this value. But it's getting invalid stack position. I wonder where it's getting it from. I can do run trace, I think. How did we use run trace before? So run trace. Oh, it runs under IO because it prints stuff out, of course. So we can say the result comes from vm.run trace of program. And then we can say result should be 6. Okay. If I run this now, we should get a lot of output. Okay, so we start off with empty stack. One of these is an instruction pointer. One of them is the stack pointer, I think. We don't care about the stack pointer in this, so empty stack. Then we push the value 2 on, then 3, which one is going to 4, then the value 4, and then the value 5. And then it stops. So invalid stack position does seem to be, it loads everything onto stack. Okay, this stack is long enough. It's got stuff on it, but we seem to have a problem getting stuff off of it. So there might be something wrong in the load. Okay, so the VM calls the stack. Let's start here. Some address. Guess, oh, I better check it really is 0. And the stack. Okay, so we just call bang bang question mark on the stack of this address. So I think that should be okay if the stack is correct and the address is correct. So back to the VM. Here we have, oh, this is correct, but it might not be. Maybe that is important actually, because otherwise you get back, I think you might get back to CPUOP first, which will be the instruction, and then you'll add 1 onto it, which is not what we want to do at all. Is it as simple as that? Nope, it's not. Okay. Oh, we have to trace as well. That's good. Okay, so a couple of things are going wrong here. We're all good up to this point. Stack is as I expect. Then we call load 0, and that's actually wrong. So by load 0, I meant this element, and it's actually loading this one, so I need to subtract from the length of this stack. So what it's doing is copying 5 onto front, but then another bad thing happens because I'm saying it should be element 2, which I expect it to be this value 4. It's actually going this way. So it's going 0, 1, 2, and grabbing the 4 from the wrong end. I'm moving it here. So you end up with 5, 4 back at the head of the list. And then adds when you get 9. Okay. So we can fix that, I guess. So we will actually modify the address so we'll get some position back where position is the length of the stack minus 1. Is it just length I want to call? The length of S minus the address. See if that works. One failure. Okay, expect it to come valid stack position. So the length of the stack, 1, 2, 3, 4, minus 0 is 4, and it's actually 0, 1, 2, 3, so I'm pointing off the end of the stack. Everything is hard. So minus 1, oops, minus the address. I might move this into some helper in a second. I'll see if I use it anywhere else. One failure, obviously. Okay, cool. Expected 6, but we got the whole thing back, including the output of the stack. Okay, cool. So, if we go back to spec, I'll just stop running it like that, and I'll just say vm.run program. Okay, cool. That worked. It's actually trickier than I expected, but it works, so that's good. Okay, back into here. This length. We are using it in places. Why is that? No brackets. We are using it in a few places, but I'm not also calling minus 1. It's interesting. So this must have compensated for the minus 1 issue. I'm a bit worried to change it now because it'll probably break colon return. I was thinking about adding a helper that would, given some address from the start of the list, turns it into position from the end of the list, and kind of hide the fact that it is just a list, because you shouldn't need to know that. It seems the only place I'm really using it is here. How does that compensate for it? Step call. It pushes something onto the stack. First, it pushes return address on, and then gets position of that. So I'm guessing it jumps back to the place before this. Don't know. Let's leave it because it works. Let's look at this issue first, I think. So what I was thinking I could do in the VM, let's get basic VM back, sorry, and the running of things. Not the running of things, the stepping of things. So what I was thinking is that we could consume that instruction. There's a couple of things actually. One is I'd like to stop pushing P into, or sending P into the functions. I'd rather just send the operand itself. And then I would kind of like to do the stack instruction pointer moving first. So can I do this? This might be a little bit tricky. So I was kind of thinking I could write something called I don't know what to call it. I want it where there's no operands. It's not even unary, it's less than that. What would be zeroary? That was a word for zeroary. But let's say no operand. And that's going to take a CPU. And it's going to just return the modified CPU. And no operand will just given some CPU, it's going to return it, but with the CPU ID. Oh, we're going to pull this out. So we see at CPU's instructor, and then CPU IP. I think we're going to pull out. It's going to be the IP is CPU IP. Oops. +1. So here, this function, which doesn't take any operands, it can just be step halt applied to no operand. Applied CPU. Okay. I'll just write it for now. I'll come back and think if I can make this syntax nicer later. Okay, so we're going to take no operand and give it to step halt, and then step halt doesn't need to consume the IP. It doesn't anyway because it stops it. Right, these take a program, so we need to think about them separately, but step return can be no operand of CPU. Getting a bit repetitive, so we can maybe fix that. These ones I can say apply this to no operand CPU, and step load, I can't say that because it takes an operand. Just going to rerun the test to make sure that still works. 8 failures. That does not work. Whoa. Oh, it's really not happy at all. Something very bad has happened. Get an instruction first. Oh, is it because halt doesn't advance? Halt just stops. I think it might be that. Could be wrong. No, let's find out. No, it wasn't that. Same failures. Okay. That's not the case. Oh, I know what. I know one thing that's a problem. I didn't update these to stop advancing. So I can take this out. means we don't need to match it here anymore. Okay, and then we can probably just stick this back in one line. Okay, so step op should work. Return, again, it's a bit of a funny thing. We don't need to advance the instruction pointer because it's going to change the instruction pointer anyway as part of its operation. So of the 3 that I changed, 2 of them shouldn't have changed. How are we doing now? Okay, everything passed. So that fixed that one. Now for these things that take a single argument, I'm wondering if I can pass in the argument directly rather than passing the program. So what I'd really like to do is change this to be word 8. I think, yeah, word 8. And it doesn't take P as an argument, it just takes V. We should be able to get rid of that. And we don't need this anymore. We'll rely on someone else to advance the instruction pointer. And then we should be able to say, just fix this, this needs from integral. Because I made it a list of ints rather than a list of word 8s. Okay. So one operand will again go from CPU, but this time I'm thinking it goes from CPU to a tuple of a word 8 and a new CPU. One operand is equal to, of CPU at CPU IP this is going to need to program. Because we need to look up the value inside the program. So here we can return tuple containing value and our new CPU, which is CPU and CPU IP equals CPU IP, oops, in this case plus 2. Or is let, I don't know why, but it just does better here. Let v equals I'm using this unsafe operator, so maybe we can have a look at that at some point. And we're going to get back CPU IP plus 1. CPU IP plus 1 in this. Okay. So now this, we can kind of use it here. So we can say one operand P in the CPU, except that one operand p of CPOP returns this tuple, and step push doesn't take a tuple, it takes 2 arguments. So I'm wondering, can you do something that uncons? Is that what I want? Maybe it's not. I thought there was a way that you could take no, it's not uncons. That was a way you could take a list and was it uncurry or something? What does uncurry do? I kind of want to take a function which is A to B to C, and the value, which is the tuple A and B, use an arrow for this, but I don't really understand arrows, and gives you back a C. It is exactly uncurry. Okay. So uncurry, and we'll give it the function. Okay. From the Haskell there. So in theory now I can go to step push and I have done this already. I've told it not to modify the instruction pointer. And do the tests still work? A lot of tests use push, so we just find out pretty quickly if it's broken. And they all pass. Okay, cool. So it's a pattern I can use for other stuff. So step call will be uncurry step call one operand step call. I need to change. It's not going to take P anymore, it's going to take some value V, and the value V is going to be of type word 8. And call address can just be from integral of V for now. This does modify the CPOP, but that's okay. Is that okay? Return address is no longer CPOP plus 2, it's just CPOP. So I could probably get rid of that and then use it directly here. Well, actually, maybe return address, maybe naming it as return address makes it clearer. Okay, let's see if this still works. That was cool. Okay, next one. So return is special. Step load. And we can do uncurry of step load applied to one operand. Again, nice step load. We'll need to not do this. And it'll get a word 8. Which is going to be just the address. And we don't need this anymore. And we should be able to join these up. Okay. So what I've done now is I've moved the modification of CPUIP out of the steps, except for ones which are control flow basically. So call and return are control flow, where they will change the instruction pointer to something. And halt is special. Shouldn't matter if I do no operand or whatever. So I'm just going to see if I can turn this into no operand. Oops. Sorry, it's in the wrong place. It should be here. Oh, no operand. See, that still works. Yeah, I can do the same thing here. So I'm just trying to turn them all into the same kind of shape. And then I can look at extracting it out in some helpers. So no operand could actually, I mean, it shouldn't do this, but it could return tuple of void. Do I want void or do I want this? The only reason we're doing that is you could then uncurry everything. Doesn't look like it's going to work. No, because it passes in this empty value as the first argument, and that's not what we want at all. Okay, let's not try doing that. So I can't uncurry them all. That's not a good abstraction. Maybe one thing I could do though is I could take the function as an argument to one operand, and I could return that. So we can maybe say we take word 8 to CPU to CPU, and we will return CPU so we're going to take program, we're going to take our CPU, take a step, and we call step with v and new CPU, where v is equal to that, and new CPU, oops, is equal to the old CPU, but with CPU IP incremented by 2. Oops. Okay, we can just call it function. Oops. Function of b. Then we can sort these around a bit, so we can say one operand b CPU and step push goes there. Not happy. Oh, that's the wrong return type. it's either a VM error or CPU. So what's wrong with this? It couldn't match these things. Okay. So I called step before. I'm just going to just type of fn. Oh, that's why. Okay. Now what I might do is actually just swap these arguments around a bit. Just stick these in here. Then we'll do a similar thing here. So there'll be one operand step call. Like that. And this will be one operand step load. Okay. So now can we get rid of... I'm thinking I can extract it. So they all in CPU. So I could say go CPU and partially apply this. Just grab that for a second and then we can say next. Click those. It does not like it. Why does not like it? Let me do the refactor in a second. Let me make no operand the same pattern. So we can say this is a function and then like that. So we can say no operand step halt. These are all no operand. Oh, tricky. Okay. No operand of step ret and CPU. Need to bracket these. There's that. There's that. I need to bracket these two as well. Okay, to fix my type here. Okay. don't know why I've suddenly broken one operand and all of that. Oh, this is a problem now. So this now needs to be either VM error or CPU. And now this needs to take the function and it's going to call the function on. Do I need the dollar there? No. Okay, they're getting closer in shape. Does it still work? It does, that's cool. Okay, so can I now pull CPU out? So these were all partially applied, so we do the thing again where we take that, delete them. So I should in theory be able to say that. Which is okay, except I'm not trying to pass CPU into here. That's annoying. Very annoying. So what I'd really like to say is something like if instructions halt, the definition is no operand step halt. And then something outside can call it. I mean, I could write something really stupid. I mean, not that stupid, but it could be backslash ignore it. That. I guess that makes it go away. Okay, can we get rid of the program as well? So if I change this so that it takes the program, but we'll just ignore it. So the function, I will ignore the program. Okay, we'll get rid of all these P's. And then I should be able to put it here. Okay, and now this takes 2 arguments. Okay, so now the steps don't need to care about programs generally. Is that true? Are there steps that do still need to program? I'm not sure if there are actually. They shouldn't need to look anything up, right? They're either going to take no operands, or they're going to take 1 in this case. And we could extend it to be 3 or 4, whatever, but and they don't need to see the program after that. They might set the instruction pointer, but they don't do that by looking at the program. They're just given that as an argument, or they get it from the stack. So I think that should work. Let's find out by running the tests. Yep, test will pass. Okay, that's cool. Oops. One last thing. So let's clear this here. Describe non-halting programs. And then it eventually stops with an error. So let program equal from list, and we'll just do vm.position and value 1, doesn't matter what it is, and then we can say vm.run program should be, and it doesn't return left, it returns the error message. So we could say something like non-terminating program. I'll come back to the VM errors in a second. All right, oh no, it joins the words together. Okay, so if I run this now, it should run forever. Oh, interesting, it did not. It tried to get the next instruction out. Okay. Let's see if we can create a loop. We don't have loops, we do have functions. So if I called return to 0, like if I return all the way back to start the program, so if I give it the value 0, so the stack just contains a 0, it's all it's got in it, and that should be the return address. And then vm.ret is that non-terminating? It is not. Empty stack. Oh, we need a return value. This doesn't work because we should be okay because the stack pointer should still point to 0. So this can be any value, I think. I think it can. Oh, okay. So writing a non-terminating program is harder than I expected. I don't want to create a new instruction just to not terminate. So what can I do? I can say, why does it think the stack is empty? Because I thought what it should be doing is pulling the last bit of the stack, which is 5, as a return value. Oh, the stack pointer will be set to 0. It'll move back to that position and then read something and then go back again, but you can't go back again from 0. Okay, I can't write a test for this, but I could make it a problem. So here, if I delete that and say 0 and run the test, this is run forever. Does not. Wow, really interesting. It's really not what I expected at all. Where have we got no operand? It's not only difficult to reproduce the problem. I guess part of the reason I wanted to do this one operand, no operand thing was to make it difficult to get this wrong, which means it's now difficult to recreate the problem to test if I fixed it. It's also not running forever. Okay, not that. I don't really know how to do this. I don't know how to make it go bad anymore. So maybe I don't need to write my my check for this anymore, because I think it's actually quite difficult to break it. Okay, forget that. What I was thinking of doing is just putting a new value in here, which is like instruction count or step count, maybe. Zero, so I need to put it, oops. I need to put it into the CPU type. And then CPU, no, not CPU, it'll be CPU step count, I guess. I'm not going to do it, but that was the idea. You put step count in there, and then every inside run, every time you call a step, I would just increase that step count, and in run, I'd add another state here. So we could say until CPU halted or CPU step count is greater than 1,000 or something. But I won't do it because I think I've actually made the problem go away with this stuff. So it's very hard to now get it to not terminate. It'll just break before that. Cool, okay. I might wrap up there. Next week I'll go back to this idea of calling a function, and I'll look at how to call it with multiple arguments. Which is essentially going to be taking stuff off the stack. So I'll need to pass an operand into call to tell it how many parameters to pass. We'll take those things off the stack and copy them into the stack frame for the function. And then we can do whatever the function does and return the last value of that. Comments coming through slow. Nullery, unary. Nullery is the word I was looking for, wasn't it? Instead of no operand. I could do that. So this would be nullery. And this would be unary. Yeah, it makes sense, because then we get a binary and tertiary, don't know. But yeah, nullery I think was the name I was looking for. Does it still work? Yeah, it works with new names. Good. Okay, cool. I'm going to leave it there. Next week I'll go back to passing parameters into functions and hopefully finish off the function stuff. And then we can go back and, when that's done, go back and have a look at how I actually compile into the bytecode for running functions. But cool, thanks for watching along, and hopefully see you next week. Goodbye.